Welcome back. This is part 3 of the video tutorial for the lab in which you are learning to measure distances using Google Earth. In this section, you will measure some very long distance or global distances using Google Maps. It's actually really pretty good for this, and you will be very briefly introduced to the notion of projection. So here's what we're going to do. You're going to have slightly different instructions, but you will return to the OVIAT library. So I'm just going to type in OVIAT library into the search window and then have Google Earth find it, Google Maps. I'm going to flip over to Maps. It seems to render faster. My computer is working slowly. And then in your instructions, you are going to measure a distance from CSUN to Beirut, Lebanon. I'm not going to do that simply because when I do that, you'll see the answers. So I'm going to start with the OVIAT library just like you will, but I'm going to type in Istanbul, Turkey. You will type in Beirut, Lebanon. So here we go. I'm going to right click on measure distance here from the OVIAT library, and now I'm going to type in, instead of Beirut, which is what you will type in, Istanbul, Turkey. It comes up on the drop-down menu. I'm going to select it. The map will refocus on Istanbul, Turkey, and I'm just going to click once on Istanbul here just above the word. You will do the same with another location. Click, and I have a measurement both in miles and in kilometers. And I believe you will answer a question at this point. So I'll press pause, and then you can come back. All right, so the next thing that you're going to do is to zoom out. So I'm rolling out with my mouse. You may zoom out using this button here in the lower right-hand corner. It may be behind my face. And what you have is a great circle distance between 2 points. The great circle distance is discussed in the lab, so you should read up on it. But essentially, this is the most direct route that you would take were you flying from Los Angeles to Istanbul, or in your case, to Beirut, Lebanon. This would be the line that you would find on a globe if you were to stretch a string between Los Angeles and Istanbul, Turkey. This is the path that string on a globe would. Google does a really excellent job of measuring the shortest distance between 2 places on a 2-dimensional map with this tool, even though the globe itself, the world, the Earth, is a 3-dimensional object. And this is how this great circle distance is how Google compensates for it. In order for you to answer the next question, what I'm asking you to do is to straighten this line out, to convert it essentially from a great circle distance to something more like a flat line distance or a rhumb line. So what I want you to do is find the apex of this arch at the top, and you will click it and drag it straight down somewhere into the North Atlantic, precisely halfway between Istanbul, or in your case Beirut, and Los Angeles. So you'll do that once, and then you will move your cursor over to the apex point of the first arch, drag it down so it is essentially parallel with the other point that you just made. Do it again, and do it 1, 2, 3, 4 more times until you have essentially a straight line. And this would look like the line that you would get if you were to plot a straight course between Los Angeles and some point in the Middle East on a flat map. But now I want you to then record once again this distance, and you should find that it's significantly longer than it would be if you were flying on the straight or the great circle distance. This distance here is a rhumb line, a straight line, and though it would help you make it from point A to point B, it is not the shortest route. Okay, so the last thing we're going to do here, I'm going to right click here and clear this measurement. The last thing that we're going to take a look at is projection. Now this map, if I zoom out to the full extent, which it pretty much is, you'll notice that Greenland looks essentially as large as Africa. But if you look at Greenland on a globe, you'll recognize that Greenland is much smaller. And there will be a subsequent lab discussing projections. This is essentially a Mercator projection or something very close to it. And the problem it has is that it greatly exaggerates the size or the area of land masses or everything poleward. You look at Antarctica, it's absolutely massive, and it's not really that big. Africa and South America are made to look much smaller. Here's a way you can check that. So just click once at the very top of Greenland, right click, measure the distance, and then bring that distance down to the very bottom part. Click again, and you will get a distance between the top and the bottom, or the northernmost and the southernmost point of Greenland. You will record that answer with Google or with Moodle, and then you will repeat that process by zooming in on Africa, giving a right click up here at the very northern tip of Tunisia, measure distance, and you will measure the distance to the very southernmost point right here of the Cape in Africa. You will enter one more answer, and I believe that is the end of this lab. Hope you enjoyed it. I hope you got all of them correct. And if you didn't, hope you understand why you did not. Check with your instructor or your TA if you did poorly, and we will certainly endeavor to help you and get them all correct.